This is AI6YM unboxing one of my T41 software-defined transceiver kits. This is the all boards kit available from my website ai6ym.radio. I'll put a link in the description below. The T41 is a software-defined HF transceiver, 10 bands, 80 meter through 6 meter. It's broken up into 7 individual modules, and then I stocked all the cabling as a kit to connect each of those modules. And that modularity really helps in customizing and upgrading this radio over time. You don't have to replace the entire thing. You can upgrade or replace a single board. But also each of these modules is useful in and of itself. It can be integrated into another open source radio project or a homebrew project, which really attracted me to this radio in the first place. And I've done my best to include every little bit and bob that you might need for each of these modules. Connectors and parts that aren't actually necessary for the T41 are included. All the individual options are populated, or at least the better ones, when choices are A or B. And I did that so that these builds can be upgraded and customized and integrated into other things. And of course, I don't know what you'll be doing with your radio. I'd like you to have the most options possible. So this is the main board kit I'm opening up now. Of course, you get the main circuit board with all the surface mount components populated, with the soft shutdown option selected in this case. Teensy microcontroller pre-programmed and included, with the current version of the software, of course. And the audio hat or audio shield for the Teensy. Some heat sinks and thermal paste for the voltage regulators, and hardware, of course. All the connectors and headers and such that you might need, along with the wiring, fan, power switch, all the little electronic devices, including a pre-programmed tiny microcontroller for the soft shutdown option. And then here it is put together. In my build, I put an extra female header between the audio hat offset board and the audio shield, and that's not necessary. It does increase the stack up height there, so I don't recommend it. In current versions of my kit and in my assembly manual, I recommend soldering those two parts together directly with a pin header strip, which really makes for a neater build. Up next is the RF board. Again, all of the options, temperature controlled crystal oscillator, both attenuators and such, are all populated on this board. The electronics through holes, all the headers and pins, enough pins for each of the jumpers and test points if you want to populate those. Some more thermal paste and a heat sink for the voltage regulator. The only thing I didn't populate on this board is the MF option, and that would have enabled 160 meter operation. That option doesn't actually work, so we'll have to publish a daughter board in the future. And here it is, fully assembled and ready to go. Next is the front panel kit, which I actually recommend you build second. This is the electronics board that controls the front panel. Switch matrix board with 18 spots for button switches. A little bit of ribbon cable to connect the encoders. All the ribbon cable connectors and headers that you need. The switches themselves. And this is one of the encoder boards. There's 4 of these included, 2 slightly different configurations of the 0 ohm resistor jumpers, and that allows 2 encoders to share a ribbon cable. And some machined aluminum encoder knobs, include 2 small ones and 2 larger ones here. And the encoders are Burns 24 ppm or PPR, and of course the headers and such that you'll need. And I really selected the parts here, and the knobs and the encoders especially, for what I wanted in my radio. All right, here it is assembled in a 3D printed case that Al Peter designed and printed for me. So I tried to do that with all of the parts and selecting higher quality options where they were available, and really what I would want in my own radio. I am building my radio from my own kits. Hopefully that quality shows through in your builds as well. Up next, let's open up the bandpass filter board. This one especially I think is a great board to integrate into any other open source or homebrew radio projects. All the electronic components for it. I've included more than enough wire to wind all of your toroid inductors and your air cores, and then the connectors that you need for it as well. This is my build. I went ahead and potted each inductor in hot melt after tuning each filter, and that really keeps them from getting out of tune, especially if you like to do POTA or something like that, where you're throwing your radio in the back of the truck and banging around the dirt roads in national parks and such. Which of course I like to do, and so I try and make my radios a little more robust. This is the low-pass filter control board. It does a lot more than that. There's a 4-antenna switch and a high-precision SWR meter and TR switch and all sorts of things built into this board. It's a great piece of engineering. And of course, 12-volt high-power relays handling up to 100 watts. All the electronics. This is the TR switch carrier board. I included all 17 SMA connectors, and all the headers and pins that you could need, and the wire that you'll need to wind the transformer for the SWR bridge. Not all of those SMA connectors are necessary. It really depends on what you're doing with your radio. But again, I wanted to make sure you had all the options available to you, so I went ahead and included all of them. Feel free not to solder on connectors that you don't need. I'd rather you have them and not need them. Here it is assembled for my radio. And then the low-pass filter board itself. This is another one that would be really good to integrate into almost any project. I'm including the toroids and the wire to handle up to 100 watts. And of course including more than enough wire for what you need winding those coils, and the connectors to the control board and all the relays for it. And here's what it looks like fully assembled. I didn't pot these inductors. They're not as sensitive to minor changes in the placement of the coils on the core, but also that high gauge wire is much harder to move around with little bumps. And this can be controlled just with 12 volts from any source. You don't need the control board if you're integrating this into another radio. Of course, the control board provides that 12 volts and lets you select a filter digitally over I2C. Right, and then finally, this is the power amplifier. This is a 20 watt PEP, or about 16 watt RMS, across all the bands, 160 to 6 meter. All the surface mount components pre-populated. Your electronics there, including the RD16HHF1 transistors, wire you need for the transformers and chokes, all the connectors and hardware that you need, and then some thermal paste and these glass mica insulators to go between the final stage transistors and the heatsink. Here it is installed in my radio. A little bit of thermal paste I need to clean up there. And as you can see, that heatsink is pre-machined for you drilled and tapped ready for your assembly. And those mica glass insulators really are a much better choice than the silicone ones. They have a much greater thermal energy transfer than most of the silicone options, and of course they insulate, which is what you need between the heatsink and the transistors. This is my interconnect cable kit. Comes with the two audio cables, two longer 12-inch 60-centimeter cables there, two 6-inches, and I'm sorry, those are 30-centimeter and 15-centimeter. The ribbon cable, power cabling, all your ribbon cable connectors. And that small twisted pair cable there is for the transmit keying of the amplifier. Basically everything you need to connect all these modules together into a functioning transceiver. Right, and that's it. There's each of the modules as I built them for my own radio. Thanks for watching, and 73 AI6YM.